Okay, we are live. Welcome everyone. Okay, audio seems to work. It's always a nice thing. So, welcome everyone, and I think this is a historical moment because as far as I know, it's the first time someone is streaming about Chapel. And when I told my friends I would be streaming about Chapel, most people didn't actually know what it is. So, what is this? It's this, as I would say, like a hidden gem of parallel programming and HPC. So let me just quickly change window. Yeah, so Chapel is this programming language developed by HPE, with whom, by the way, I'm not affiliated, just to be clear, which is meant to make parallel programming fast, fast to write, so like save human time, and also fun to write and easy to write. So that's kind of the mission of Chapel. So a language for HPC to make HPC more accessible to people, to researchers. And this stream will actually not deal much about the language itself, so not about like language properties, language features, not that much about programming. But I'll definitely have more streams if I find enough people interested in Chapel. This stream will be more about meta features or like soft skills around the Chapel, so to speak. So in a way will be like a workflow of how to develop libraries in Chapel, how to structure libraries, how to structure projects in Chapel, how to structure your code, how to build the documentation, how to write unit tests, and this kind of stuff. So it will be kind of like development workflow tutorial. And I hope I'll also put this stream in YouTube afterwards, so will be like for the people in the future also. And it was pretty fun to prepare for this stream because while preparing I found a couple of bugs here and there, and it was fun to like fix stuff at the last moment. But it's okay, it is what it is. It's the fun thing of streaming. So let's start, as I said, from scratches, how to develop your next super cool Chapel project. And to prove that we start from zero, I'm starting from the most basic thing we can start of, an empty terminal. So that's the starting point. Of course, I have Chapel installed, so we can verify. I can do chpl, so Chapel, the compiler, -- version. So I have Chapel 1.33, the latest stable version. Then a few tools that we use when we build libraries and projects with Chapel. One is Chapel doc, so chpl doc, which is this library for building documentation in Chapel. So to build the documentation with Chapel. And as you can see, the same version is the version is 1.33, so the same version of Chapel, because it's actually shipped with Chapel. So when you install Chapel, you automatically also have a Chapel doc. Because documentation is important, you should always write the documentation when you write code. So whenever you install Chapel, you always also get the tool to write documentation. So you have no excuses. Cannot say haven't installed it. It's already there because documentation is important. Then another important tool that we will use is Meson. This is also shipped with Chapel in the sense that if you clone the Chapel repository, Meson is there, but you need to manually build it when you install Chapel. And Meson is the Chapel package manager in a way, so it's used to start projects, build the libraries, build applications, publish your projects, unit tests, test your libraries, and so on and so on. So it's package manager for Chapel libraries. Perfect. Now that we know the tools, so we need Chapel, of course, the compiler, Chapel doc for the documentation, and Meson for structuring our projects and our libraries. The next thing that we want to do is to start the project. And when I start a project with Chapel, I will do with Meson new. And then basically there are two things two types of projects I can start with Meson. Well, actually three, but we will talk about only two. So one is application and one is a library. So I could start, for example, my cool app. So if I do Meson new, my cool app, it says created new application project. We can verify that we have a folder called my cool app, which built an app. So this is one application. Second one is a library. So I can do Meson new my cool library. And to tell Meson that now I want to start a library, I need to add the flag --lib for library. Now it says created new library, my cool library. And what is the difference between an application and a library? Well, you can think of an application as kind of final product, so something that you want to compile to executable binary and you want to give the binary to your audience so that they can actually use it. This is the application. The library is something that you want to integrate inside other Chapel projects, inside other Chapel code. So for example, if I'm a researcher, most of the times if I develop research software, I probably want to write a library. So a library for differential equations, for automatic differentiation, for root finding, whatever. A library that other people, other researchers, other people in industry or academia can include in their Chapel project. So library is something that is included in other Chapel projects, included in other Chapel code, whereas application is a full final product. So something that you want to finally compile to a binary and execute and just give the binary to the end users, for example, who don't need to write any Chapel code after that. That's the difference in a nutshell. And how do they differ, this application and this library? Well, to answer that, we can notice that in both cases, when I created the app and the library, it created a folder, and inside the folder I have in both cases a source folder where the source code will go, and this project and this file meson.toml. And let's start to have a look at the meson.toml in both cases. So let's start with the app. So it's a TOML file, and you can see here it has application, so type application, so it says it's an application, and then it has basic information about the project, the application that we started. So the name, the version, which by default is 0.1.0, the version of Chapel which I'm using, so the version of Chapel which I used to create, in this case 1.33, and the license, which at the moment is none because I haven't added any license. Whereas if we look at the library, then we see the type is library. So that's one difference. In this meson.toml file, it has this type field that tells us if it's a library or if it's an application. Another difference is that if I look at the source folder, for example, for the application, I have for the application this function main, this function called main inside the application. Whereas if I look at the library, I don't have any function main. And that's another difference, that when I have application, I will have this main function, and I must have it, which is the entry point of the binary. So what is executed when I execute the application. But if I have a library, I don't have this main function, because generally I don't want to execute a library. I want to include it in some other code, which is then executed. So that's the main difference. Yes. Now we can start to play a bit with this library and start doing things, start making it a bit more substantial. So as I said, the difference is minimal now between like library and application. Application has the main function, library has not. Then they are differentiating this mason.toml file, which is this file for identifying the basic properties of the project. So the name, you can add the author, the license, the version of Chapel, dependencies, if you add some dependencies, and so on and so on. Yeah. So let's enter, for example, the library. And let's see what we can do with this. So a good starting point is that if we don't know how to use Meson, we don't know what to do, we can always ask for help. And we can ask for help to people. Yeah, exactly. It's analogous to Cargo in Rust. Yeah, Meson is very cool. Yeah, exactly. It's I mean, I haven't used much Rust, but to my understanding, it's pretty much the same idea of Cargo in Rust, or like pip or the 7000 more in Python. But yeah, I was saying if we don't know how to use a command, a tool in Chapel, we can always ask for help, and we can ask for help from people, of course, always. But we can also ask from the tool itself for help. So I can do Meson -- help, and it will print me a list of commands. So we see now what can I do with Meson. I can do Meson new, which is what I just did. Then I can do Meson init, which is similar to new. The only difference is that with Meson new, I was creating like a new folder. With Meson init, you initialize an existing folder. So, you start like prototyping in a single Chapel file, like in a dirty like file, and then you realize, oh, my idea is actually pretty good. I should package this into something. It's like, like happens that you start prototyping in a single file, and then you realize, oh, I should package it. Then if you already have a file, you can package it with Meson init. Add, to add a dependency. rm, to remove a dependency. Build and run. This is what we will talk soon a bit more. Search, which actually at this moment doesn't work. I found a small issue with that, but in principle search is to see all the packages registered in Meson and see what is there. And yeah, I mean, clean, to remove like binaries file that are generated by build or run. Doc, to generate a very simple documentation. System external is to add dependencies which are not Chapel dependencies, so a bit more advanced way of adding dependencies, like for example, if you have C libraries, you want to add some C libraries that you have installed in your computer, so like more advanced dependency manager. And publish, to publish your library into the Meson registry. And what we will mainly use is build, run. And maybe what is the difference between build and run? Now we are in library, so we will only use build. Run is only for application. So what run does for an application, remember application has this main function which can actually be executed. Run will build and run the application, so execute main function. Whereas build will simply like compile the binary. And if we have a library, remember, a library is not something that you want to execute standalone, it's something that you want to integrate in other projects, so a library can only be built. Test, for running the test. And we'll see a bit also about doc, like how to use Meson doc, but then we'll see also how to use Chapel doc if you want more flexibility. So let's start to, for example, build the library. So we can do Meson build. Yeah, first time might take a while. And build is successful, which is pretty like reassuring because I don't have any code. So if I don't have code, I also shouldn't have bugs. So it would be pretty worrying if I managed to have actually issues without having any code. So, but it worked. So like first smoke sanity check passed. And let's see what happened now that we built it. So we see now our folder changed, and we have two new things. We have mason.lock and target folder. Let's start with what is inside the target folder. So we see now we have 3 folders inside the target folder. So target debug, which has the binary of my library, which will do nothing. Then target example, which will have the binaries of the examples, and target test, which will have the binaries of the test. So in a nutshell, target is where the binaries are compiled into, and debug is where it compiles the library itself. So the source code is compiled into a binary here. Example, if I have some examples, so I could have a folder example. So I could have a folder example, and if I have this folder with some examples showing how to use my library, then when I build the examples and run the examples, it will run this one. And similar test, which is empty because I don't have tests, is where the tests are built to run the tests. So target is where the binaries are put when it compiles the code. And then we also have this mason.lock file, which appeared when I did that. Let's look at it. And I mean, at the moment, now it's pretty, boring, because I don't have any dependencies. So it actually looks like the mason.toml file. So I have root. So root stands for my project itself, so my cool library. And I have pretty much repeated the same information of the mason.toml in this case. So the Chapel version, which I'm using, license, which is no license, it's a library, and the version. However, the difference between mason.lock and mason.toml comes when you have dependencies in your project. So when you add some other libraries, because then what will happen? Let's try to add a dependency. So, for example, if I want to add okay, let's see, for example, where if I want to add I said that you can have libraries registered in Mason. Let's see where that is. So there's this repository in the Chapel in the Chapel organization called Mason Registry, which is a registry, a community registry of libraries registered in Mason. And if you go into bricks, I have this theory that the Chapel has like building theme, like bricks, Chapel, Mason. So I think it has something to do with buildings, but I'm not sure. I should ask the developers if it's like a joke about buildings. Yeah, but in this bricks folder in the registry, we have a list of packages which are registered at the moment. So we have a Hello World package, which is mainly, example for testing. We have a forward mode ID, so library for automatic differentiation, which is actually my library. So the first library which I registered in Mason, which at the moment is a bit outdated, but I'm updating that to the new version. Should be ready soon. And so here in this Mason registry, we can see what we have, like what is registered in Mason. And if I want, for example, if I want to add this Hello World, yeah, exactly. It's the small equivalent of crate for Rust. A brick is like a crate, I guess. Yeah. So if I want to add, for example, this Hello World library, I can do Mason add Hello World at and the version. It says adding Mason dependency Hello World. And now, well, if we look again at the mason.lock, nothing changed. But now if we do Mason update, actually, let's first look at the mason.toml. We see now we have a dependency, Hello World. So it says, okay, this library needs the library hello world. And now if we do Meson update, and we look again at meson.lock, we see now something happened. So we have more information. Your screen is still showing the browser. Oh, sorry. Thank you. I forgot to change your scene. Wrong one. Okay. Okay, so let's go back. So, okay, then... okay, now I added this hello world. Now let's remove it so we can do it again and see what and how changes. So Meson remove hello world. Meson update. Okay. Now we are where we were, like when I forgot to change the screen. And I was saying, suppose we want to add a dependency. So suppose this my cool library needs hello world. What I can do is Meson add hello world and the version which I want to add. And now if we look at what happened, Meson.lock is the same as before for now. But if we look at Meson.toml, this dependencies section, field, whatever it's called, has a new entry, hello world 0.1.0. So we have registered that my package depends on 0.1.0. So that needs a hello world at least 0.1.0. And now if I do Meson update, what happens is that Meson will look into the Meson.toml. And now if we look at Meson.lock, we see it has changed. We have new info about this hello world. And if you compare to what it was showing in the .toml file, it had only one line, like hello world version 0.1.0. Now here what it has, well, the name, the source, so where is this hello world, what chapel version it needs, and the version again. So where I'm going is that the difference in a nutshell is that the Meson.toml simply like lists what dependencies I have, what dependencies my project has, whereas the Meson.lock is a more specific version which, well, locks every version of each dependency. And when I do Meson update, you see, if you remember before Meson update, so between Meson add and Meson update, the toml changed, had a new entry, but the lock not yet. When I do Meson update, what happens is so-called dependency resolution. So it goes through Meson.toml, sees the list of dependencies, and tries to resolve the dependencies. So tries for each dependency to find the latest version that can be used. Like it was saying that hello world needed at least 0.1.0, which is also the latest, so it picked that one. And also hello world didn't have any dependency, so it was, pretty boring. But if my dependency has dependencies, so like recursive dependencies, they will be listed in the Meson.lock. So Meson.lock will go through the dependencies and dependencies of dependencies and dependencies of dependencies of dependencies and so on and so on and so on, and try to find the appropriate versions. So that's actually combinatorially pretty interesting graph problem. This dependency resolution is NP hard actually, I think. But yeah, package managers can do it. So it's pretty doable with some heuristics. So yeah, that's the difference in a nutshell. Meson.toml, basic information and list of dependencies. Meson.lock, detailed informations about what version of each dependency is used. And now there's kind of question, when should we, do we want to keep the Meson.lock? Do we not want to keep it? So I think when I did Meson new, it also generated a .gitignore. And if you look at the gitignore, so the files to ignore in Git that were generated, it has indeed the target, obviously, like you don't want to commit to the repository, the binaries which are generated, and Meson.lock. And this is typical for libraries. So in general, for libraries, you don't want to include Meson.lock because you always want to resolve and use the latest possible version. And you kind of hope that people follow semantic versioning, So, properly mark the new version if it's breaking or not, so that if you have like patch release which is not breaking, you can upgrade automatically. Of course, sometimes it doesn't happen and things break and you have to fix it, but that's life. But in general, for libraries, you may not want to to commit the Mason.lock and always resolve every time the dependencies. Whereas for applications, most of the times you want to keep the Mason.lock, because for applications you want a final binary that you can execute, that you give to people who don't need to write more code. So people who only want to execute it. And often you want that binary to be built with exactly the tested version, because that's kind of the production application. So that's also a rule of thumb that for libraries, generally don't include Mason.lock. For applications, include it. And I think we can check. I'm not sure. But if we go into my cool app that we created before, we can see how is the git ignore here. Okay, it also git ignores the Mason.lock here. But it's an app, depends what you want to do with. Do you want to make it reproducible if it's like experiment of a paper, and you want to make sure that it's absolutely reproducible? Then you want to make sure that every person uses the exact same version of every dependency, so that everyone gets the exact same result. So if you want to freeze everything and make it reproducible, you include the Mason.lock. And if you don't, if you want like to simply have some constraints, or like what is the lowest bound of the version that is supported and so on, but you want otherwise to resolve and find the latest possible working version, then you do not include the Mason.lock. Yeah. I'm a bit surprised it's git ignored in the app also. I would have thought to not git ignore for the app. But yeah, so that was how dependencies are handled. So to recap, we have this Mason add to add the dependencies which are registered in the Mason registry. Mason rm to remove. You can also add, if you have a Chapel library which is not registered in Mason but is on Git, you can add that directly from the Mason.toml file. So you could here, for example, do hello world and then directly put the link. Or I think it's something like git equal and the link. There's an example in documentation. So you could also add directly to Chapel libraries which are in some Git repository which are not registered. You can also add C libraries or like libraries like other libraries, external libraries. It's a bit more complicated. Maybe one thing worth mentioning is that if the library you want to use is in this SPAC package manager, so yeah, this SPAC is like package manager, kind of like a repository of libraries for especially like HPC people, fairly popular in HPC. Mason has also good support for adding directly libraries from SPAC. So if you need some C library, if it's registered in SPAC, then it's easier, almost as seamless as adding from Mason. Yeah. So I guess to call myself Chapel streamer, I should write at least one line of code of Chapel. So far I had Mason write all my Chapel code. So let's do something. Let's start to so I go into my cool library, and you see I have this module, my cool library. It's common convention to have one module per file, and if I'm not mistaken, I'm not super sure, but if I'm not mistaken, it's not even strictly needed. So even if you don't have module my cool library for the file, Chapel will automatically treat each file as a module. I'm not super sure, but I think it is. But anyway, if I recall like what I was told once, it's like better practice to explicitly write module and the name of the module match the file name to make it more explicit and clearer. But yeah, maybe let's define a function that greets someone. So proc is how you define a function. So it stands for procedure. Let's call it myFun, which let's say it takes your name, which is a string, and returns a string. And returns a new string, hello plus name. So maybe just a small comment. So proc stands for procedure, is a keyword to define the function. myFun, name of the function, maybe I can call it greeting, makes a bit more sense. Input variable, name of type string, output type is a string, and then we need a return keyword, and this plus now is a string concatenation. So we'll write hello and name. Cool. Let's build it. Let's check that the library builds. I hope I didn't forget any Meson update in the middle, that everything is up to date. Build is successful, nice. And as I was saying, it's a library, it's not executing anything, so it's a bit boring. But what we can do to showcase how the library works, we can add an example. So I can do Meson in example. I will create a file, example1.chapel. And here I can, in example further, I can add examples to showcase how the library works. So first of all, I want to use my library, so I want to import it. And to do this, I will use my cool library. And now I can use my library. So this is called greeting, greetings, greeting Luca. Oh, I gave my name away. Maybe I should have used coding math, whatever. Yeah, and maybe I want to write it so that I see that happens. So write line to print. Let me just check it was greeting. Yeah, greeting. And greeting. Yeah, I think I got it right. And now I think I can do example. Yeah. So you see, I didn't remember by heart, but I kind of remembered I can do Meson run example, and then I double check Meson run -- help, and it says yeah, Meson run run -- example to run the examples. Yeah, and if I want, I can also give, if I have many examples, if I don't want to run all of them, if I do live demo, I want to run only a specific file, I can give a list of files of which files I want to run. But otherwise, I can also I can just do -- example and we'll run all the examples. So Meson run -- example. Ah, okay. So that's not true. Meson build -- example. Okay, I think I should be able to run examples though, because it's an example. Yeah. Now it says compiled example1.chapel. So now if we look at target, our example folder, which before was empty, now has a binary. And now I can run that. It says, hello, Luca. So it works. Yeah, we ran our first example. What does a hello world do? If it has any function, maybe we can showcase how to use it. Ah, yeah, doesn't matter. Okay, cool. So to recap, we saw how to add the dependencies, how to remove dependencies, to remember to use Meson update in the middle, to update the meson.log file. And then we saw where we can write code and how to write examples, and Meson build -- example to build the example, and then run the examples. I think so. I can do Meson clean if I want to remove the target. So I want to remove all the binaries that I built. You know, I did some experiments. I want to start from clean table. I remove all the binaries. Now I'm curious if I just do Meson build, will it build only the library or also build the examples by default? Okay, now let's see target and example, and it's empty. Okay, so Meson build builds only the library. Meson build dash dash example builds the examples. Nice. Next thing we want to do, probably, most likely, is that we want to test our library. So we want to make sure that our library works as expected. So how to write unit tests? First of all, we want to put the unit tests in a folder called test. So let's make it. And then similar to Meson build example, which was like running everything in the example folder, when I do Meson test, it will run all the tests in the test folder. So now it says, okay, there were no tests, so everything works as expected. Remember, you cannot have bugs if you don't have code, so you cannot have errors if you don't have codes. So far everything works nice. Now let's see how to write some tests. So let's create a new file. Let's call it, I don't know, test file.chapel. And first of all, we want to use our library probably if we want to test it. So we do use my cool library. Then to write unit tests, we want to use this Chapel library called the unit test. Not surprising. If you want to read more about that, in the Chapel documentation, modules, utilities, no, tool support unit test. And here you have documentation of unit test, and you can see like what functions it support. Well, mainly like, so it has this assert equal to check if few things are equal, check if two things are not equal, check if one thing is greater than the other, and so on and so on. Yeah, let's go back to code. Now, maybe one thing that we may want to do when we run unit tests is that we want to structure our tests in groups. Like if I have multiple, now my library has only one function that says hello Luca, so it's arguably not much to test. But maybe we want to check that the library has one group of tests for one functionality, one group for another functionality, and so on and so on. And the way I structure unit tests in group in Chapel is by defining them in specific functions. And that needs like a bit like of things to remember, so it needs to be written in a specific way. But it's a function, so I'll write proc test group 1, for example. Then the peculiar things that we need is that it takes as input a variable which is of type test, and its keyword borrowed. It refers like to memory management, like how it's like the class. So this test is a class, and how like it's managed, how it's passed. And then we want to add at the end the keyword throws. Why? Because in Chapel, if a function can throw an error, so if we need like some error handling, then we need to specifically say with the keyword throws at the end of the function that the function may throw an error, that the function may return an error. Otherwise, it would be like a bit funky behavior, like if it throws when it's not expected to throw. So we want to take as input test, which is of a type of a class test, borrowed from test, and the function can throw, because we have tests. That's the whole point of test, that they can fail, so can throw. And then here we can write our test using this assert equal, assert not equal, and the functionalities of unit test module. Again, you can always check from the documentation what function it has. But, for example, we can check that test.assert equal. So assert equal is a method of the class test. So test.assert equal. We want to check, for example, that greeting Luca is equal to, well, what was it? Hello, Luca. So this could be one test. Yeah. Then let's make just another group, test group 2. Test, and for example, assert not equal greeting Luca. This should not be equal to hello John, for example. Now, arguably, these two tests. Oh, I'm not sharing the terminal again. Oops. Okay, here we are. So I just defined the second group, test group 2, with a very similar test, but that says that the checks that greetings Luca is not equal to hello John. Like, arguably, from architectural perspective, these two tests, they test the same function. They're very similar, so arguably they should go inside the same function, inside the same group, because they test the same functionality. But I wanted to demo like how to have multiple tests. Yep. Oh no. And last thing to remember, so to recap, we need use unit test to use the unit test module. We group, if you want to group tests in group, we can do it with functions, so one function per group. And yeah, then the function should throw, so keyword throws, because test can fail, so could throw an exception. And should take as input something borrowed from the class test. And then we can add like assert equal, assert not equal methods, and so on and so on. You can also have dependencies between tests. So for example, you can say run this test or like this group if the previous one passed, and so on. So you can specify these things. You can skip tests if some tests are expected to fail, and so on. So you have a bunch of functionalities. Last thing, in the end, we need to actually run the unit tests, and this is done by doing unit test.main. What this unit test.main will do, will execute these functions. So now let's test. Now we can do Meson test. Yeah, it has two tests passed, so not much info. But now let's mess up the test a bit, just to check what happens if I have errors in my test. So let's go back. In test file. Generally, like, the test should fail because I have a bug in my code, but let's now just mess up the test. So what I did, I changed from Luca to Luke. So now it will print hello Luke instead of hello Luca. So it will not be equal. So this assert equal will fail. And probably for the demo I should remove the hello world dependency, because if you have dependencies, compilation is a bit slower because you have more stuff to compile. So to make the demo a bit slicker, could remove that. Okay, it says failed. So it says, okay, assertion error, could set the string hello look is different from hello Luca. So it says, okay, this test failed. So let's now show another thing. So this was like failure. So, like the function didn't behave as expected. That did not behave as expected because I changed the input. Generally, it's because of a bug in the code, but just to simulate it. Now, let's do something different. So let's introduce a syntax error, for example, so that the code does not compile. So this was like functionality issue, like valid code, but not doing what we're supposed to do. Now, suppose my code does not compile. So maybe let's go to the source code. And the easiest way to mess up compilation, remove semicolon. And let's do now Meson test. Yeah, and now it failed. So now it was very fast because it couldn't compile at all, so didn't even try to run anything. But it says, okay, error failed to compile, which is not very informative as an error message. So by default, if you only do Meson test, it will give a very short summary, which is, definitely okay if everything passes, because if everything passes, you don't care about anything else. It's most of the times okay if it's assertion error, because the summary is enough, and the unit test module has pretty nice debugging messages, so it's pretty nice. But generally, if the problem is compilation, if your code does not compile, then Meson test alone by default does not give a lot of information. It's very short. But then it also tells you that you can do Meson test -- show, and if you do -- show, it will show, well, more information. Particularly if there are compilation errors, it will show also those. Now it says, okay, so line 6 near this, yeah, I'm not sure. Yeah, I mean, it's a bit better. But yeah, so now it kind of printed also the error of the compiler. So this is like if I tried to compile the file manually, what it would print. So now we can fix that. So we were, okay, there's an issue at line 6. So here. And we notice, oh, there's a semicolon missing. And now we can do done test again. Okay, now it passed, so now everything passes. And notice also that when I do Meson test with a show, -- show, it also prints a short summary for each group. So it says group 1, okay, group 2, okay. Whereas if I do without show, it only prints this summary, okay. So to recap, Meson test to test our library, -- show to get more information. Yeah, and let's recap how to write unit test. So test in the you have a folder called the test where you put all the test files that you want. And if you only do Meson test, it will run all the test files. If you only want to run a specific test files, you can give like a file name. For example, what was it called? Meson test file.chapel. Which now is the same because I only have a test file, but it's useful. Like first you run everything, then you see what fails, and then you start debug one file at a time. You can focus on a specific file. Yeah. And notice also that it doesn't print, without the show, doesn't print this summary per each group. Okay, we are so far we have seen like how to write code, how to write well, first of all, how to get started, how to start the project, Meson new or Meson init if you are already in a folder with some Chapel code. Then we have seen where to write code, source folder, Meson build to compile. If you have an application, Meson run will also run your application, so execute the code. How to write tests. So far though, everything has been local in my computer. And I'm not going to give you my computer, so you cannot use this. So what we want next, we want, for example, to publish this to GitHub, for example. Yeah. And actually, when I did Meson new, you can say this is a repository. So Meson new also initializes as repository. So now what I can do, I can push this to a repository. So I can push to GitHub. So let me just go to GitHub. And let me create a new repository. Which I will call my cool app. Example, Chapel library. And I want to make it empty because I want to push from my file, from my, yeah, I guess I wanted to call it my cool library. Can I still edit this? Oh, that was easy. Oh, okay. I guess because it's empty. So otherwise I think should ask more confirmation and stuff. But yeah, now we want to push. So I want to add the remote. And now git, we want to add everything. Yeah, I'm already in main. Git and push. And now we have the repository. From like open source code perspective, it's not very good because I don't have a README, I don't have a license, so there's these kind of social aspects which I didn't consider here. But you should add a README describing what it does. You should have a license definitely. But now there's another thing I want to focus on, which is I want to automate running tests. So yeah, you can write a README on your own. You can add a license. That's things you can do. But another thing I want to do, I want to set up like a CI pipeline so that I can always automatically run the tests. Because at the moment, if someone opens a pull request to my code and wants to contribute, changes something, I need to check out their branch, run my test locally, and so on, which is a bit annoying. So I want to automate the thing. Yeah, and let me just quickly check if I have actions enabled, or if I need to change that. Yeah, I think actions are enabled by default. Maybe I think I want to give read and write. Yeah. It's those are stuff that you always copy paste once in a while and always forget how to do. But yeah, now I want to add automated pipeline so that I can always automatically run all the tests. And I actually didn't find much how to do it, so I wrote my own. So let me go to this like real library. And this is the action I'm using. So this I use GitHub Actions. And actually, if you're interested, oh, sorry, I'm not sharing. Yeah. So I was saying, I didn't find like from the documentation like template you should do that way. So I wrote my own action for that. So that's kind of, you know, how I'm doing it. Yeah, and so this is the action I use, very minimalistic. If you want, there was some discussion. So if we go to the Chapel discourse, so this is a Chapel forum where there's all discussions about Chapel, and there was from a while back. Oh, from quite a while back actually. Okay, because it was very short time ago, but yeah. So I, as I was saying, I didn't find anything, so I asked like, how do people do it? And oh, I also opened an issue. Yeah, so this is, and also I listed my own, and then there was other discussion how other people are doing it. So if you want, you can also check other ways of doing it. Mine is very minimalistic, like I want like, you know, I had very simple requirements, so I want very minimal action. But then there were a few people who also described like more sophisticated actions if you need like more control, more sophisticated control. But yeah, this is the action I'm using. So it's called the CI. What it does, I basically run the test whenever I push to main, which is never, but you know, when I merge pull a request into main, when I create a new tag, so when I make a new release, and when I open a pull request to main. And what I do, as I said, it's like very simply. So I run on Ubuntu. I use this image, so this fetches from Docker Hub the Docker image of the latest Chapel stable release, and yeah, like I'm not. So if it's only Chapel / Chapel, it's the latest stable, so 1.33 at the moment. But for example, when I wrote this, it was when I first wrote forward mode ID, it was like 1.28, and so what happens this way is that if it updates to the new stable, it will automatically use the new one, and this might cause a few issues. So maybe what you want to do is that you want to put colon 1.33 and pin what version you use on CI and manually update when the new version of Chapel. Yeah. Except 2.0 should be coming pretty soon. So with the new 2.0 version, it will follow semantic version and there will be way less like breaking changes. So maybe using automatically the latest stable release, it's okay. But yeah, I think when I started this library, since there were a few changes, I should have pinned the version. Now I'm paying the price of that. So I pull the Docker image, so container containing installed Chapel, and then I simply run Meson test. That's also something that like I changed recently on the library. It's not merged yet, but I realized that indeed on CI you probably want to run Meson test -- show, because if for example what happened in my library is that when I upgraded to the new version of Chapel, there were a few issues. It wasn't compiling, and since I was only doing Meson test, I didn't know the issue. So Meson test -- show I would say is much better on CI to use. Yeah. And for Mac, I do very simple thing, except that I don't need to pull the Docker image. I can directly install via Brew. So if you use Mac, Chapel is available in Brew. It's mainly the same of installing manually. There are small differences, but I can install it from Brew. Actually, don't remember if this was needed or was simply like more efficient that running both on Mac and Linux via Docker image. I think maybe this is a bit faster than pulling the Docker image. I don't remember why I want it separated, Linux and Mac. But yeah, now I'll simply copy paste this. And let's go back to the terminal. And now, so what I want to do, I want to create a folder called .github, which is where I put all like GitHub related things. So could have also other things like issues template, pull request template, and stuff like that. I generally like to put all my workflows inside a folder called workflows. So I will create another folder called .github workflows, but you don't need to do that. Could also be in .github. Now I'll create the action and I'll simply copy paste what I had. And as I was saying, I want to use -- meson test -- show, so that if there are compilation issues, I see that. Yeah, now I have new file. Now let's commit this. So add the CI for automatic unit testing, and let's push. Now, yeah, I shouldn't do it. I should maybe make pull a request to main. You know, it's the proper way that you never push directly to main. You always go through pull requests so that main stays clean and working. But for this small code, let's just do like this. Now let's go back to the repository, but not this one. Yeah, let's go back to our just created repository. And now you see something new happened. Now that I have this action, there's this yellow light here saying that it's pending, so it's running. And let's run it as on Linux and on Mac. And if everything goes fine, it should pass because it's only running meson test. But yeah, maybe while we wait for the test to run, since I mentioned a bit discourse and documentation, I could go a few more pointers. So I guess the general resource is this Chapel documentation if you want to learn about Chapel. Very self-contained, a lot of information. I mean, pretty much all the information you can need because it's documentation. One thing I really like is that it has this language specification section, which has a very systematic description of the language, even like systematic at level of having like composition rules of the language, which, you know, since I'm pretty much into programming language theories and compilers, that's cool to me. It's arguably a bit dry for beginners, but also this is not meant for beginners, the language specification. But it's nice that you have when you get more advanced with Chapel, it's nice to have this very systematic description of the whole language. But then you have this primers section, which is kind of more like a summary of the language specification, but more like tutorial style, very beginner friendly. So this this is the beginner friendly. So this is where you should go if you're a beginner, to the primers. Yeah, and then if we go to tools, Meson, this Meson guide describes in details what I showed today, with more information also, with more things. Yeah, so documentation. Discourse. So this is the forum of Chapel where you can ask questions. There are different categories like users if you're using, developers more for internals, social for like social interactions, and so on. There's also Gitter chat, which I will not display now because it's a chat of people, but it's open to everyone. You can find it actually from the documentation. I think there's the link. Or not? Oh, maybe from the website. Yeah, so from the Chapel language website. there's a link to Gitter chat, this one, the pink one, where you can chat with people and ask more like chatting questions. And then of course there's the Chapel repository itself, where if you find issues or pull or like feature requests, you can open an issue. People are very friendly, very reactive. I opened like 4 issues today before this stream, so yeah, I think it's important to highlight these social aspects because it's like the even more important than coding. Okay, it's still running the test, but it takes a while, maybe the first time. Oh no, it ran. Okay, nice. It lagged in the interface. But yeah, it ran everything and you see green check, so our test pass. And now if some, someone with bad intentions opens a pull request and changes the code, instead of hello, says goodbye. This is a very important change. This pull request does not do anything bad. You can merge it. So now someone shady, I mean, look, they have the picture of a yellow frog, so it must be someone shady. Says, this PR does not do anything bad, you can merge it. Now because we have our unit tests on CI, we will immediately see that, hey, this does something bad, it's breaking the test. Yep. So we saw how to structure the project. We saw how to write unit tests. We saw how to write those automatically in GitHub. We didn't see like how to add, README and license, but you can add the file. There's one last thing I want to discuss, which is how to document the code, which is, kind of arguably one of the most important things. You should have always documentation. So I want to talk about this Chapel doc. Yeah. And one thing we did not discuss in this stream is how to actually write Chapel code. So it's kind of preparation, how to set up everything to code, but did not really code anything. But maybe we'll have upcoming streams with more like programming and developing. I can do some live coding of Chapel stuff in upcoming streams. Okay, now I kind of remember also I wanted Brew because it's faster, because Mac already did. And now this person says, yeah, this code doesn't do anything bad. But now because we have automated testing, we catch them. Haha, something breaks. Yeah, and that says, hey, goodbye Luca is different from hello Luca. Yeah, not sure about this part, like how informative it is, but can be useful, I guess. It says, hey, the test fails. Group 2 passes, group 1 fails, and here's the failure. So now we can, sorry, but this looks fishy. And we can close it. Okay, now let's see how to document our code as last part. We have 5 people in the chat, and I don't know how many people are watching because I think Twitch does not live update the number of watchers, but 6 viewers maybe. Cool. 6 people passionate about Chapel. Cool. In a few years we'll be 600 watching Chapel streams. But yeah, let's go back to here and let's talk about how to write documentation. So I will not maybe do the whole like setup also because there, I mean, not like, you know, deploy actions and everything, because there's still a bit like a man of works and corners. Also, I need to smooth in my own workflow, but just the main idea. So let's go to the code. So Vim source, my code library. And you see on top of the module, there's this doc string, so this comment, and when it's like slash asterisk slash, this like multi-line comment. So I think, I don't remember RST by heart, but basically I can write code. So documentation for my code library. Hello, this very cool library is very polite and greets people. Okay. So the simplest way to write documentation is, well, simply to add comments before functions or before modules. So now this here, this doc string here, this comment before the module, is the generic documentation of the module. Then I can do the same thing here. So I can do oh, sorry. Yep, I was just thinking Finnish keyboard. So I can write here function, and I can write, for example, short description. This function says hello to a person. And if you want to like document input and outputs, you can use some special syntax. So for example, if I want to document the input type, I can do :arg, then the name of the variable name, and then describe the name of the person I want to greet. I can specify the type, :arg, type name, and say it's a string. And then I can write like returns a polite greeting, rtype to specify the output type, so a string. So basically I add a comment, multi-line comment with a slash asterisk before the function. And then I can use this special syntax like :arg name, :arg, close colon, to like list like the input types, :type, close colon, the input, the types of the inputs, returns to describe what is returned by the function, and the return type. And if you want a more systematic description, here we can go to documentation, Chapel doc, and has described the syntax. Why do I want this special syntax? Like, what is the idea? The idea is that so basically Chapel uses Sphinx, if you know it, to Sphinx to build the documentation, and the Sphinx understands that special syntax and will render the doc strings in a special way. And if you are like, if you're not very picky with your documentation and you simply want to document every function in your code and list every function with the doc string, then it's fairly easy. You can do Mason doc. Yeah, and when we run Mason doc, you see a new folder, doc appears. And this folder has the generated HTML of the documentation. So you see, it generates the documentation. Now I have, okay, there are a few things to adjust, but my cool library, it says, it generates how to import for the library. So for the module, it says, hey, you can do use or import of the library. this is the text that we wrote, and this is how it's rendered. So that's why we're using the special types return type, because it displays them in this tabular way and lists the function. So if you're happy with this, if you simply want all the doc strings, you can just do meson doc, and then, for example, use the GitHub Actions action to push from the doc folder to GitHub Actions and to GitHub Pages. Sorry, so you can use GitHub Pages action to push to GitHub Pages branch and deploy from there. It's free from GitHub. You can do that. I am a bit pickier with my docs, so I don't think of documentation just of bag of doc strings. I like to add the tutorials. Like to add the stuff and so on. So what I like to do, but this is still a bit like work in progress. Also in my workflow has some manual work. I'm planning to smooth it a bit and maybe automate. Maybe I'll do on stream in upcoming streams and put some like actions or like some scripts to automate the generation of the doc. But basically what I do is that, first of all, if we do meson doc again, we see that meson doc is not anything magic, but it simply calls a chapel doc. So it says, okay, chapel doc, so the tool to generate documentation. It says, okay, create this here, so generate documentation from my cool library.chapel, which is the main file of your library. -- process used modules means that if you have other files that are imported inside this file, it will also generate documentation for that, and save that inside the doc folder. This kind of like hack which I came up with is that what I do chapel doc, what I do, source my cool library doc, then I do, what is it called, save Sphinx, I think. Wait a minute. Save a Sphinx. So I save the temporary Sphinx file which are used to generate HTML. So meson doc will just generate the final HTML, but I don't want that because I want to generate a different HTML. I want to have more control of how my documentation is structured. What I do chapel doc dash source my whole library chapel. Yeah, we can save in doc, save Sphinx in docs folder, and I'll skip the error in a known location. That doesn't look good. Maybe I don't need the space. Okay. Yes, I had a typo. Oh, I'm in the wrong place. Sorry. So I see the problem. You see, I was in the doc folder. Sorry. So that's why it was failing. I should be in the library root folder when I call chapel doc. Yeah. So I want to save the Sphinx in docs folder. Everything is going surprisingly smooth in this stream. I haven't had a single error so far. It's weird. Yeah, so now you see what I did. I have this doc folder, which is the generate HTML, and actually I don't want that, so I'll just remove it. And then I have this docs folder, and if we see what is inside this docs folder, is kind of intermediate steps. So if you're familiar with Sphinx, this is typical Sphinx structure. So Sphinx is this no, not this one. Is this a tool for building documentation, very popular, very powerful, used for example for Python libraries. And what I did with Chapel doc save Sphinx, I simply generated the intermediate step of generating the Sphinx folder, the Sphinx file. And so what Mason doc does, it generates these files, this docs folder, and then from these uses Sphinx to build the HTML. But I don't want the HTML generated automatically because I want to tune stuff a bit. Yeah, and so now we can see what is here. So we have this build folder, which is where a Sphinx would build the HTML. So Mason doc then moves from build to doc. Actually, I think we want to git ignore that. I mean, I'm sure we want to git ignore. So let me add. Yeah. Now we have a make file for Sphinx to build. And now we have this index.rst, and this rst stands for rich, S stands for something text, rich something text, which is kind of like Markdown, a bit like heavier syntax, but also a bit more powerful syntax. So in Sphinx, you write all your documentation as RST files, and you can write tutorials as RST, allows like to link between files, allows to have LaTeX, to have code snippets, and so on and so on. And if we look at these modules, we have this mycoollibrary.rst, which is this RST file with the generated documentation from the docstrings. So in these modules folder is where all the docstrings get dumped. Yeah. One thing that we want to do is we want to go to this conf.py, and there are a few things that we want to customize. This is okay, this is okay. So we want to change, for example, the name of the project. Then author text, maybe we want to change, so it's the author. Yeah, copyright we can change, or we can use default, whatever it does. So if it's greater, oh, okay, so it says from 2015, probably want to change 24. So will be copyright 2024 Luca Ferranti in this case. I think most of the other things are pretty okay. So by default, the theme will be a bit different, so it will not look blue as I showed. If you want to add the theme, so the blue thing that I was showing before, this is this Read the Docs theme. So Read the Docs is this popular website to host the documentation. If you want this, you can add here HTML theme, Sphinx Read the Docs theme, for example. And then last thing you want to do, there are you need to add in docs a file requirements.txt, which needs at least one thing, which is let me check. So this requirements.txt, you want to add this Sphinx contrib chapel domain to have support for chapel sample syntax lite. And then, for example, if you want to, if you don't have this Sphinx RTD theme installed, you want to add as requirements so that when it builds the documentation, it installs the theme, this blue theme, this popular theme. Yeah. And this way, you have more control. So inside source, I can create a new file like tutorial.rst and start writing a tutorial. Yeah, so on. I can customize pages, I can add more tutorials, more like background theory, for example, and so on and so on. For hosting, then the documentation, if you use a Sphinx, probably the easiest way is to use this read the docs, which is, for example, what I use for Word Mode AD. So my documentation is hosted in this read the docs. If you want to host it here in read the docs, it's fairly straightforward. You log in to read the docs. And then you can add your repository. One thing that you need to do is that you need to add this. You need to add to the. So if you use read the docs, you need to add this .read the docs.yaml file. Which is actually fairly well documented in read the docs. And if you use a Sphinx, basically you want to copy paste this file and add it in the root of your repository. vim.readthedocs.yaml. And one thing that you want to do, which I didn't do yesterday when I was upgrading my library. So this is new thing for read the docs, I think. When I started my library, it wasn't needed, but now you need this YAML file. And you want to install the requirements. Here. So you want to say, hey, install these requirements. And then, yeah, the default it has this conf.py file with all the configurations like name of the author and so on. Oh. Yeah, I was saying when you copy paste this read the docs YAML file, you at the very bottom, by default is commented out, but you want to use this thing that you install the requirements. So this requirements.txt, so you have Chapel Syntax Lite and the read the docs theme if you want to use it. And if you use the structure generated by Chapel doc, the conf.py file is inside source. See? Yeah. And now you have more flexibility. Now you have more power. Now you can write like manual files and so on. There's still a bit of a glitch, which I haven't automated yet. So I'm kind of working on some tool to automate that also in my libraries, which is if I update. So now I have the cool docs folder all set up with all my tutorials. But then if I want to like generate new doc strings, I change the source code, I need to update the doc strings. Then at the moment I kind of need to do it manually to generate a temp file with all the Sphinx files and then copy the new modules file from this temp folder into docs folder. So what I mean is that now I have the docs, which is nice and clean with all the setup. Now if I change my documentation, whatever. If I change my documentation, like some doc string, now I cannot overwrite the docs folder. So what I want to do, I want to save this in some temp folder and then move the modules. So thought you do it this way. Oh, whatever. But anyway, I need to move like this modules folder inside docs. So I'm also trying to automate a bit more. Would be nice. I want, like, my goal also with these streams is like to lower the barrier to Chapel and make it more accessible to everyone. So I'm also thinking of making like package template so that everything I did it manually today, make CI actions and documentation deployment and setting tests, everything is already automated so that you can skip my stream and go straight into like writing Chapel code. So like kind of write a template to automate everything I have explained today to make it more lower threshold to people. But yep, otherwise that's how you set up documentation. And if you don't want any fancy tutorials, you don't want to customize your structure, you can simply do Meson doc and you have HTML and then you can push to GitHub pages and deploy the ready HTML. Easy peasy. And you can also have like Makefile, for example, some Makefile to more fancy stuff. So what I discussed now could be automated with a Makefile to automate the documentation building. Yeah. So this was a crash course on building libraries in Chapel. We haven't seen how to publish to Meson, but that's actually not like I don't want to like spam the repository with my example, but you can see from the documentation Meson guide publish submit a package, and here has instruction to like publish to the Meson registry. So yeah, this was a crash course on how to develop libraries in Chapel. We saw like how to set up with Meson New, how to get started, what is the structure, what is Meson.toml, Meson.lock, the difference. Meson.toml has like broad overview of the package. Meson.lock registers specific information about all dependencies and dependencies of dependencies, dependencies of dependencies, and so on. How to write unit tests, how to test, how to write examples, how to run examples, how to set up documentation. And yeah, I hope in not so long time I'm very happy to hear you liked it, and I will definitely do more Chapel streams in the future. Actually, I'm working on a learning resource for Chapel, which will come out soon. Maybe I'll do the launch on stream, but there will be a few more learning resources for Chapel coming soon. And yeah, hope to see a bunch of Meson, a bunch of new libraries in Meson, a bunch of new Chapel projects and new Chapel users. And if you liked my stream, stay tuned, follow, and you can get notifications of when I go live. I stream about Chapel, sometimes also about other programming languages like Julia mainly, Chapel, Julia, AI stuff, theorem proving stuff. I mean, it's coding maths, so like intersection between maths and programming. And stay tuned for next streams. Thank you for following. Oh, thank you, Gumix, for following. Hope to see you again.